Hello to everyone listening today and taking the time to learn more about structural blind rivets. So my name is Christoph Blunk. I'm working for Howmet Fastening Systems for nearly 4 years now, and I was also working in the field of mechanical joining technology in my previous jobs. So in 2010, I achieved a diploma in industrial engineering on the tightness and load-bearing capacity of mechanical joint connections with blind rivets and lockbolts. And yeah, later stayed a couple of more years at the University of Rostock and the Fraunhofer Institution. And yeah, always worked in the field of mechanical joining before starting my role at Howmet Fastening Systems. So I have nearly 15 years of experience in these technologies, and I hope I can, give some of my knowledge to you today. And if you feel that you have questions, please, as Anna said, enter your questions in the chat, and I will try to answer all the questions at the end of the presentation. If it's too many questions, we will also answer by email later on after the presentation. So feel free, anything that comes up to your mind that you want to know, let us know and we will try to answer. So there's just a little bit information about my history. So also some of the research we are involved as Howmet Fastening Systems. So we are still working closely with research institutes and universities on the load-bearing behavior of mechanical fasteners like blind fasteners and also lockbolts. So if you are interested in any of these research, let us know and we can give you also here further information. Howmet Fastening System is a manufacturer of structural fasteners like lockbolts, but also a wide variety of blind fasteners. And today I want to speak about structural blind fasteners, which we are mainly producing for the European market in our Telford location, United Kingdom. And due to the wide variety of blind fasteners available on the market, there are quite a few challenges when trying to use these in structural applications. Most people consider blind fasteners rather as a commodity and don't see these as structural fasteners or for structural components. But due to the wide variety, we also have high strength blind fasteners available, and this is the main focus of today's presentation. And I want to give you a short introduction. What is a structural blind fastener? Basically, a blind fastener itself consists of two pieces, the so-called pin, and which is made of hardened material, usually a hardened steel, and a sleeve, or which is made usually of a softer material because it will be deformed during the installation. And blind fastener can also be made of aluminum or stainless steels or even other materials. But today we will focus mainly on steel fasteners made from carbon steel. And the main feature of a structural blind fastener is that we have a combination of the load-bearing capacity of the pin and the sleeve. And so during the installation procedure, the pin will be locked to the sleeve, so it won't come loose during the service life of our construction, which will be a permanent connection. And therefore, we have a very good load-bearing behavior. The main advantages of structural blind fasteners is a fast and easy installation. You get very reproducible results during installation. So there's hardly any friction involved, like when you install a conventional nut and bolt. So the preload often is dependent on the surface condition of the fastener. And another big advantage of blind fasteners is, of course, the one-sided accessibility only. So you don't need access to both sides. So you can even join hollow structures or some complex structures where the access to the rear is limited, as we can see here in the picture, which is a high-rack building. And you could imagine if you want to join all these joints here in such a structure, by conventional fasteners, nut and bolt, then this will be a lot of maintenance effort and also installation effort. When you use a blind fastener, the installation is very quick. It usually takes only 1 to 2 seconds once you hit the button of the tool and the pin breaks, the installation is complete. We will see later on a schematic how it's done. And also structural blind fasteners are normally non-self-loosening, so you don't have to take any maintenance measures or safe securing measures like for a nut and bolt, for example, especially if you look at very low diameter grip range ratios where loaded joint is not possible, and due to the characteristic of the blind fasteners, which are often hole filling due to the installation procedure, you have a form fitting joint, so there's hardly any movement between the components possible, which also allows for transferring of fatigue loads. So this is a very big advantage in comparison to conventional fastening methods like nut and bolt. The advantages have resulted in a wide range of applications of our structural blind fasteners. So our fasteners can be found in the truck and trailer industry, but also, as we've seen, in construction industry. They're mostly used in Rivet application, even, for example, if you want to join dissimilar materials like aluminum and steel. In the solar industry, they are very appreciated due to the quick installation and high volume of fasteners used there. And also there's often limited access to the structures. Material handling we have just seen on the picture, for example. And automotive industry is also a big field of application for blinds. And of course, the wind industry is also a growing market, especially here for internals inside of towers or the nacelle, where you don't want any maintenance. The corrosion resistance depends often on the field of application. So we have a wide range of corrosion protection systems available. I will have a slide about that later on. And as I mentioned before, the fatigue resistance is in most applications critical. So we have tested our fasteners in this regard, and I will also show on later some results about that. As I mentioned, the wide variety of blind fasteners available at the market comes also with a lot of challenges. I already mentioned that these fasteners have a different geometry. The material of the sleeve is often different to the pin material, so we have different strengths and ductility of these materials. There's little standardization of these products available, so you can't calculate the resistance of such a fastener in the same way as you would do it for a conventional nut and bolt. Also, as you can see here in the schematic picture on the bottom right, that depending on the type of blind fastener, there is also a challenge in regard to the cross section of the fastener. So even if you see, for example, here on the left hand side, our Magna lock fastener, we have fully locked pin inside the sleeve, but the pin is partially hollow, so the cross-section varies along the axis of the rivet, and therefore there's this has to be considered if you design a joint, and because all the material properties are not easily available. We have done some extensive testing with our fasteners, and I will show some results later. Here on the right-hand side, I also included a non-structural fastener. So here we don't have any pin lock on the rivet head. So here would only the shear loads would only be transferred through the sleeve, which is usually very soft. So this would result in a very low shear resistance of the rivet or the connection, and therefore this all these points have to be taken into account when you design a joint. And also another problem is that we have often only values from data sheets available, which give a good indication about the performance of the products, but not necessarily about the performance of the connection or the joint. So normally blind fasteners are tested according to the ISO 14589 standard. So there are hardened inserts used for the tensile or shear test, and so a certain shear or tensile resistance is determined and usually published. But the problem is this test, for example, does not take into account the component characteristics. So for example, the thickness of the sheets or the strength of the component material. And all this does have a big influence on the load-bearing characteristic of connection. So for example, if you see here, under shear load, you could see, for example, that if you have a very thin sheet, for example, there would be a hole elongation under shear load if the load-bearing capacity is exceeded, and also there could be some inclination of the rivet due to some bending of the components if you have very soft or thin sheets. And also a pull-out of the fastener could occur. But if you have, for example, high-strength materials, also the fastener could shear off due to overstressing, and therefore it's a very complex situation, and most people are usually not familiar with these characteristics. So same applies for tensile loads. Here you can also see a failure of the fastener itself, or pull out of the fastener from a sheet, or pull through a sheet. It's always a combination of the thickness, strength of the material, and also number of sheets to be joined. So that's a very complex situation, which often cannot be determined just by calculation, like for a conventional fastener. And therefore we did a lot of testing with our products and obtained a so-called DIBt approval, which is a approval from the German Technical Building Authority. And so we did not only tensile and shear tests with the fasteners itself, but also on connections with different material combinations. And so we got specific results for our fasteners, which then can be used for the design and calculation of the joint resistance. And besides the static tests, we also did a lot of fatigue tests with different connections or combinations, and derived a so-called notch factor for our fasteners, which are also published in the technical approval. So at the moment, our Magna Lock fastener is covered by the technical approval with a protrusion head, also with a sunk head, and also the Magna bulb fastener is included in the national technical approval. But we have done in the recent years a lot of further tests. So very soon there will also be our structural BOM fastener included in the approval. We have also included a smaller diameter 4.8 millimeters fastener from the Magna-Lock type, and also new materials, stainless materials for the Magna-Lock fasteners are now included or will be soon included in the national technical approval. We have tested further corrosion protection systems to have enhanced corrosion protection for our blinds. We have also tested our complete hole filling rivets, which is a enhancement of the conventional Magna-Lock product, and also a new diameter for the Magna-Lock, the R11, which is a substitute for 10 millimeter nut and bolts. This will also be included in our approval. So we have now, or will then have a very wide range. And how does such a approval work? Usually you can see which of the fasteners are included in the approval. They have a general description of the geometry of the fasteners, but also you will find values for the static and fatigue resistance. So for very thin sheets where, for example, a combination of the resistance is often found. So where not only the fastener fails, but also the sheet is plastically deformed during loading. And there we have special tables where you can see and or search for the material you are planning to use. And then you can check the sheet thickness for component 1 and 2. And then you find the characteristic resistance for this type of combination or sheet combination in the approval, which then can be used for the calculation of the joint. So we have these for shear forces and also for tensile forces. And this is available for different fasteners, as I mentioned before. We also have a table with fatigue resistances of the blinds. So here you can find notch factors for notch types for the fatigue resistance for our blind fasteners under shear and tensile loads. And this allows us to use our blind fasteners even in such structural structures like a bridge. Here on the right hand side, for example, you can see a repair solution for a steel bridge which was damaged due to weld cracks. So due to the higher usage of the bridges, there often come damages, especially in welded areas. And because these are hollow sections which can't be accessed from the inside to reinforce the structure. Here, in this case, our BOM fastener was used to attach these reinforcement plate to the hollow section, and this is accessible component. So here you can see it's accessible from the rear. So there was a conventional HV bolt used, but this is a very highly loaded joint or repair structure, and therefore the fatigue resistance is also very critical. To make the calculation of the blind fasteners a little bit easier, we are also working in a working group for the establishment of such design rules, as you are probably aware of that, which are available for nuts and bolts already, but not so much for the blind fasteners. So we have at the moment two parts. One is for the general introduction in the blind rivet technology, and the second part deals completely with the calculation of blind fasteners under static and alternating stress. So some applications which cannot be covered by the DIBt approval can then be calculated with the help of this technical guideline. At the moment, it's only available in German language, but I expect the English version to be ready within this year. So it shouldn't take too much time until this will be available at the EFB organization. And then you can also calculate certain joints with the help of this technical guideline. Besides blinds, we also work on these in this committee on the design guidelines for lockbolt systems. Just for your information, I have held another webinar some time ago about lockbolt applications, and so here you can find also more information. So what kind of structural blind products do we offer? I already mentioned the Magna Lock rivet, which is available in a wide range of different diameters. So smallest diameter would be 4.8 millimeter, and it's up to ½ inch, so around 12.7 millimeters available. Also available in aluminum and stainless steel. So this is one of our popular fasteners, and therefore it's also covered by the DIBt approval. It has a very wide grip range, so with one fastener length you can usually join a big variety of sheet combinations. So this allows to limit or reduce the required fastener length, and therefore it's very popular with our customers. It can also be used with a sunk head or a flush head, and also with a large head for softer materials, for example. And it has a very good hole filling capacity. As you can see, the pin is pulled into the sleeve, which expands depending on the sheet thickness. So you have a very tight connection with without any room left between the sleeve and the whole wall, and so it's a very fatigue resistant and tight connection. The Magna bulb is a little bit different from the working principle. So here when the pin is pulled into the sleeve does not expand, it does fold. So it builds a very big closing head on the blind side of the joint. And this is very advantageous for thin sheets, or if you have tensile loads in your connections. So if you use the Magna Lock, so the tensile resistance will of course be limited due to the limitations in expanding the sleeve in radial direction. But with the Magna bulb, we do have proper solution for tensile and loaded joints and thin sheets with extraordinary high shear resistance. So you can see that the pin is also nearly fully filled inside of the sleeve. We don't have any hollow sections, which allows for an extra high shear resistance. And the Huck lock is a little bit of a combination of these both two. So you have also a very high grip range with a certain pin length, but also a larger closing head, which allows again for better tensile resistance and also thinner sheets. And for automatic installations, for example, in the automotive industry, there's also the Autobolt available. This has a special rounded feature on the pin end. So this allows for easy installation into prefabricated holes. So automated installation is here much easier, and fast installation can be done. The general installation procedure can be seen on YouTube. We do also have a YouTube channel where all our products can be seen during installation and how they are used. And as I mentioned before, if you have a sleeve expanding rivet, usually you place the tool on the pin tail of the fastener. Then when you hit the button, the pin tail is gripped and pulled into the nose of the tool. This forces the sleeve to expand until the sleeve basically touches the hole. And when the pin is fully inserted into the sleeve, the load increases until the pin tail snaps off and at a pre-designed pin break. So we have a kind of flat pin break here, which is flat with the head of the rivet, so you don't have any extra protrusion, or also it's assured that the pin is fully locked into the sleeve and won't come loose under high loads or vibration loads. This is a very good feature for structural rivets, and not all products does have these, especially certain competitors don't have these features, and therefore there's always a risk of loosening the pin and then losing a lot of structural integrity of the joint. The blind fastener with the highest load bearing capacity is our so-called BOM fastener, which is a blind oversized mechanical lock fastener. Here we have a sleeve folding similar to our Magna bulb, but on top of this we also have on the installation side a so-called collar, which is plastically deformed during the installation and guarantees a high resistance pin lock with very high shear resistance, but also clamp load on the joint. So this allows for very high dynamic loaded structures, as we have seen in the picture before, this repair solution for the bridges. So basically this is our strongest fastener in the blind portfolio, and is available up to sizes of around 19 millimeters, so there can very high loads be transferred. And this is quite impressive if you've seen this in action. And also on the right hand side you can see how much clamp is generated during the installation. So if you have a highly dynamic loaded joint, this might be your fastener of choice. The BOM fastener is already quite old, so I think in the 60s or 70s it was invented for the first time, and since then a little bit changed from time to time, but in general it stayed the same. Now we have invented a new generation of the BOM fastener, which is called the BOMtail. So the main feature of the BOMtail is that we don't have any pin rake anymore. So this allows us to use basically different coatings on the fastener. We don't have any pin rake anymore. The fastener itself is also very resistant against vibration and also maintenance free, as most of our fasteners, or all of our fasteners. And yes, as I said, the installation is fast, very accurate, and repeatable with a very ergonomic assembly. So you don't have any shock loads anymore during the installation caused by the pin break. So it's a lot more convenient for the installers to use this type of fastener. And since we have no pin break, the corrosion protection is completely surrounded, or completely surrounds the fastener. There's no bare steel after installation. And due to the new design, also the installation loads are reduced because we don't have to exceed the pin break load. And this allows for a longer tool life, and also for installation with battery tools. Normally the installation loads for the conventional BOM are higher, and therefore there the capacity of battery tools is limited. So this is our newest product, which is widely used in the solar industry, and here you can see the fastener in action. So it's very good for joining hollow structures, even with a curved surface, because the collar is quite soft compared to the pin, and adapts to the surface of the structure, and this allows for very tight and structural joint. Depending on the applications, we have also a wide variety of coating systems available. So here on the bottom of this table, you can find the different coating options for our different types of fasteners. So depending on your needs, let us know what you expect from the corrosion resistance of the fastener, and then we will find and select with you the right coating system to meet your needs and achieve or assure that you have a basically maintenance-free joint. So once installed, you don't have to touch it ever again. I also mentioned shortly the installation is often done with battery tools nowadays, but we still have, especially for factories, or hydraulic tools or pneumatic tools available. But outside in the fields, it's often more convenient to use a battery tool. So therefore, if you have any concerns regarding this, let us know, and we will find the right solution for you. So depending on the type of fastener, the diameter of fastener, there's a wide range of joining methods available. So these are the general installation methods here just mentioned. So I don't want to go too much into detail about that. But as I said, if you have any questions or special needs, please let us know. So that's mainly the technical content of the presentation. I now want to close the presentation with some pictures of typical applications. We have already seen in a previous slide the solar solar applications where hollow pipes are joined with our BOM fasteners or BOMtail fasteners. You can also see here the panels which are joined with our fasteners. So there's a wide range available, or a wide range of applications where our fasteners or blind fasteners especially can be very beneficial. We have already seen the warehousing or high rack warehouses, but also, as I mentioned, in the railway industry, the components are joined often by blind fasteners or other structural products from our from us. So here you can also see some bobtails. So this just should give you a little bit of impression how these fasteners can be used, and often the speed of installation and accessibility to the joint is key for our customers, which then gives them a big advantage to reduce the installation costs. So as a summary, the Huck structural blind rivets are engineered for a fast, safe, and accurate installation. So you have very little variation between these installations, and it's done within a few seconds only. The profession of the qualification of the personnel is quite needs to be quite low. So a normal training on the job is usually sufficient to qualify someone for installing our structural fasteners. As I mentioned, the installation is very fast. We have, compared to other products, an unmatched static, fatigue, and vibration resistance. It's quite unique that we have also fatigue resistance determined for our fasteners. That's typically something our competitors do not have. And with our fasteners, you can achieve maintenance-free joints. So once installed, you don't have to touch it ever again. This can also save significantly costs during the service life of a structure, and therefore be very beneficial for the customers. And if you have certain needs for your structure and you can't find the right solution in our catalog, we also do make customized fasteners. So don't hesitate to ask for such a solution or discuss with our engineers. We are always open for a conversation to support you in finding the right fastener. So please let us know. And as Anna mentioned before, we do have already a few webinars available on our website, and in the near future we will also let you know about new topics which we will cover in further seminars or webinars. The existing webinars can be accessed via YouTube. We will also share the presentation later on, so you don't have to take a screenshot or photograph here, take a picture of the QR code. You will receive the presentation later on. Also, if you have general inquiries about our products, please visit our website or send an email to our team in Telford, and you will, they will get in touch with you and help you with your questions. Our sales teams is based throughout Europe. So if you want to contact the salesperson directly, here you have also the QR codes for the different salespeople in the different regions. So this will be also included in the presentation later on, and you can get in touch